Hi guys, this is Arpana from Sri Venkateshwara College of Engineering of Electronics and Communication Engineering. So today I'm going to explain you about the concept of electromagnetic and its application. Table of contents are listed below. Introduction to electromagnetic concepts, electric charge and electric field, magnetic field and induction, electromagnetic waves and applications of electromagnetic waves in the field of communication, medicine and technology, electromagnetic spectrum, Maxwell equation, electromagnetic compatibility, interference, fields in nature, levitation and so on. First is introduction to electromagnetic concepts. So electromagnetism, which is a branch of the physics that will be dealing with the study of the electromagnetic forces. It also encompasses the interaction between the electric charges and the currents as well as a magnetic field by what they will be generating. These phenomena they will be describing by Maxwell equations, which is a set of the fundamental equations that are governed by the electromagnetic behavior. Electric charge and electric field. Even electric charge is also a fundamental property of matter, either positive or negative. There will be like charges which will be repelling each other and opposite charges which will be attracted. The unit of the electric charge is coulomb, which is denoted by the symbol C. So as we can observe in this figure, there are the like charges which will be repelling each other as well as the opposite charges. They will be that means attract each other. An electric field is a region around a charged object where other charges experience a force, and the strength of the electric field is determined by the magnitude of the charge creating in it. The electric field lines they will be representing the direction and strength of the field. So from this image we can easily understand that whatever the like charges are there, they are getting repelling, and unlike charges they were attracting. And these lines, whatever the direction is there, they will be representing these are the electric field lines which will be representing the direction and the strength. Magnetic field. So it is a region around a magnet or current carrying wire where the magnetic forces are exacted. So from this image, we can easily observe the magnetic fields. They are traveling, that means they are connecting from North Pole to the South Pole in a form of the closed loop. So here we can see magnetic field lines form a closed loop and point from North Pole to South Pole. And the strength of the magnetic field is measured in terms of the Tesla, which is denoted by the symbol T. Electromagnetic induction. So it is also one of the process of generating an electromotive force, which is a EMF in a circuit by changing the magnetic flux through it. So here we will be using one of the law, that is Faraday's law of electromagnetic induction. It is states that the EMF induced is proportional to the rate of change of magnetic flux. And this phenomena it is the basis for generating the electricity in power plants as well as in the electric generators. Next, electromagnetic waves. So electromagnetic waves are the transverse waves that will be consisting of the electric as well as a magnetic fields oscillating perpendicular to each other. And these waves they will be traveling at a speed of light in a vacuum, that is about 3 into 10 power 8 meter per second. So examples for this are radio waves, microwaves, infrared waves, visible light, ultraviolet, X-rays and the gamma rays. So as we can from this image, that is there is a magnetic field, electric field as well as a propagation direct, and in between the magnetic field there will be a wavelength which is denoted in the lambda. Applications of electromagnetic waves in the field of communication. So radio waves are used for the communication, broadcasting and also wireless networking, right? And also microwaves are employed in the radar system, microwaves and the satellite communication. Infrared is generally utilized for the remote controls like the thermal imaging and also heat therapy. So how the radio waves are transmitting. So as we can see, whatever the sound waves are there, from the microphone they are converted to the modulated carrier wave. So by using the audio amplifier, whatever the modulated carrier wave, they are amplified and later they will be transmitted to the broadcasting antenna. Applications of electromagnetic waves in the field of medicine. So generally we can see mainly that X-rays and MRI, which is we will be using for the scanning the body, right? So first the X-rays, which are used for the medical imaging to visualize the internal structures, and MRI is nothing but the magnetic resonance imaging, which will be using a strong magnetic fields and also the radio waves in order to generate the detailed images of the body. And also electromagnetic therapy, which is employed for pain relief and the tissue healing. And here we can see applications of electromagnetic wave in the medical imaging and therapy. So these have transferred medical imaging and therapy by aiding in diagnosis and treating diseases with the increased precision. So X-rays and CT scans, they will be using a high energy waves which are effective in detecting the fractures, tumors and also the internal tissues. And MRI and ultrasound, they will be using radio and sound waves respectively in order to provide a detailed images without ionizing the radiation, and excellent for amazing examining the soft tissues and also the monitoring pregnancies without harmful for the babies. Radiotherapy, they will be utilizing a high energy waves in order to target and eliminate the cancer cells and so on. Then applications of electromagnetic waves in the field of technology. So in the field of technology, there are many applications. In that, mainly they will be listed below. Visible light, which is essential for the illumination, displays, and optical communications. Then ultraviolet light, which is utilized in the sterilization, security markings, and also the fluorescent lightning. Lasers, which will be producing a coherent light, which will be finding in the applications in surgery, barcode scanning and also the data storage. Electromagnetic spectrum. So it will be also encompasses all the possible frequencies of electromagnetic radiation. So the range will be in the form of low frequency radio waves to the high frequency gamma rays. So it will be using both the frequencies of radio waves as well as the gamma rays. But in radio waves there will be a low frequency. In gamma rays there will be a high frequency. Different regions of the spectrum, they will be having a diverse applications in science, technology, and also day to day life. Maxwell equations. So, Maxwell equations are a set of four differential equations that will be describing how the electric as well as the magnetic fields, they will be interacting, and they unify the electricity as well as the magnetism into a single theory of electromagnetism. These equations were formulated by the James Clerk Maxwell in the 19th century, and as we can observe in this figure, there are different that is a set of four differential equations in the form of differential as well as the integral form. Next is electromagnetic compatibility. So electromagnetic compatibility, which is the ability of the electronic devices in order to operate without the interference in their electromagnetic environment. And also it stands to ensure that devices do not emit the excessive electromagnetic radiation or susceptible to external interference. Compliance with the EMC, that is electromagnetic compatibility regulations, which is a crucial for the reliability and safety of the electronic systems. Electromagnetic interference. Electromagnetic interference is the disruption of electronic devices. They will be caused by the electromagnetic radiations from the external sources. We will be using common sources like power lines, motors, cell phones, and the radio transmitter. Shielding, filtering, and grounding are the techniques which will be used in order to mitigate the EMI effects, that is electromagnetic interference. Electromagnetic fields in the nature. So generally, these Earth's magnet, whatever the field is there, it will be protecting the planet from the solar wind and also the cosmic radiations. Electromagnetic fields are generated by the lightning, the sun, and the Earth's core. Animals like birds, bees can navigate using the Earth's magnetic field. So as we can observe in this figure, so that the Earth's magnetic field is like North magnetic pole, geographic North Pole, and geographic South Pole and South magnetic poles. There will be two magnetic poles. Electromagnetic levitation. So it will be using a magnetic fields in order to suspend the objects in the mid-air. And this technology is generally employed in the Magwell trains where the superconducting magnets levitate and they will propel to the train. Electromagnetic levitation is also used in the material handling, bearings, and the vibration isolations. Electromagnetic energy harvesting. So electromagnetic energy harvesting, it will be involving the ambient electromagnetic radiation into the usable energy. This technology, it will be using a wireless sensors, that means used in the wireless sensor networks, IoT networks, and also IoT devices, and also wearable electronics. RF is nothing but the radio frequency energy harvesting and also electromagnetic induction. These are the common methods which we will be using in order, that means in the case of electromagnetic energy harvesting. Electromagnetic propulsion. Electromagnetic propulsion system, they will be using the electromagnetic fields in order to generate the thrust without traditional propellants. Ion thrusters and the electromagnetic drive systems are the examples for the advanced propulsion technologies. And also, they will be enabling the spacecraft in order to travel faster and the more efficiently in the space. So, as we can easily observe in these images also. Electromagnetic heating. Induction heating, it will be utilizing the electromagnetic induction. Why means because to heat the electrically conductive materials. This technology, they will be used in the metal processing, welding, and also the cooking applications. Like it may be, there are many cooking items which we will be using. Then microwave ovens employ the electromagnetic waves to heat and also cook food quickly and also efficiently. So what are the basics means, in figure 1 we can observe that an electrical current through a conductive material, it will be inducing a magnetic field. Whatever the magnetic field is, that inside a multi-drum coil is magnified, and a alternating current through the coil, it will be induces the eddy current in the component. Electromagnetic sensors. Electromagnetic sensors, they will be detect the changes in the electric as well as the magnetic fields to measure the various physical parameters. Examples like metal detectors, proximity sensors, and the magnetic compasses. These sensors, they will be find applications in security, navigation, robotics, and industrial automations. So there are many sensors like reed switch, magnetic proximity sensor, Hall effect magnetic sensor, and the magnetoresistive electron element sensor. Future trends in the electromagnetic technology. Advancements in the materials may lead to new electromagnetic devices with the unique properties. And nowadays there is a many wireless connections, or there in future also there will be wireless power transfer technologies. It may be evolving in order to enable the charging devices without the physical connections. And also quantum technology such as quantum communication, quantum computing, it may revolutionize how we harness electromagnetic phenomenon. So conclusion, electromagnetism, which is a fundamental force that will be governing the many aspects of our universe as well as a technology. Its applications are a wide ranging from powering our house to exploring the depths of a space, understanding and harnessing the power of electromagnetism, which is essential for shaping the future of the science and technology, and forming atoms on molecules, generating lights. So there are many applications which will be useful, and from that there will be advantage as well as a disadvantages in the future also. So thank you for giving such an opportunity to explain about the concept of electromagnetic waves.